Assalamualaikum to Dr. Khairul and fellow friends. We are from Group 1 and for today we will present about the comparison of the effectiveness of ICP-MS and AAS in determining heavy metals. Our group consists of 5 people. Me, Aina Shakira with metric number 205188, Afiq Aiman with metric number 205586, Nurul Fatihah, metric number 205626, Nurul Izzah, metric number 205791, and Wanur Sabrina with metric number 205899. In our presentation, there will be an introduction, instrumental methods, data analysis, conclusion, and also future prospect. So now, I will start our presentation with an introduction. ICP-MS, or known as inductively coupled plasma mass spectrometry, is an instrument that can help to determine the entire amount of element present in a sample by separates the ionic analytes depending on their chemical structure. Normally, the scientists will make ICP-MS as the great option because most of the challenging analytical tasks can be handled by this powerful instrument. Another instrument is AAS, or known as atomic absorption spectrometry. AAS is helpful in trace metal analysis. Not only that, but it also can monitor contamination and control the quality as well as the quick assessment of raw materials. The most interesting part is it can be used in a variety of situations. So now, I will pass to our next presenter.
Hi, I'm Izzah with matrix number 205791. Next, I'm going to talk about the type of analysis in both journals. First is quantitative analysis. Certain color additives are required to be batch certified by the FDA prior to their use in products, and representative samples must undergo quantitative analysis to determine the specified elements. Next is color additive analysis. Most color additives are analyzed for mercury by X-ray fluorescence spectrometry, but certain color additives do not give the required sensitivity or have interference from major components that suppress the much smaller mercury signal. And lastly, chemical analysis. The concept of treatment at the selected wastewater treatment plant is based on mechanical biological treatment of sewage and industrial water on the principle of low load activation with nitrification and upstream denitrification with an automated control system for all technological processes. And then each sample was subjected to a basic chemical analysis. Chemical oxygen demand was determined by using potassium dichromate, which is using the method in cubes. After that, both samples were then appropriately pre-treated and analyzed by AAS and also ICP-MS. I will continue to our next part, which is method benefits for science. The first benefit is it can analyze specific elements because of the unique light absorbent qualities of their atoms. And for the liquid samples, it also can provide direct analysis. Next, the benefits of both methods in science is they work accurately with very small sample sizes, making it rapid, efficient, and also economical as a testing method, and this is because it has a greater sensitivity than other methods with less limitations. Besides that, the benefits is virtually eliminating operator errors. This guarantees superior reliability of both the system and the analytical results that they generate. In addition, every result can be traced back to each step of the analysis, including the sample preparation. Therefore, the IC system is ideal for complex scientific analysis as well as serving as a powerful and easy-to-use tool for routine analysis. Lastly, the benefits is it is ideal for complex scientific analysis. For example, in environmental testing, it can measure the concentration of various elements in rivers, drinking water, and seawater. The technique also supports the critical testing in the nuclear industry, where there could be potentially hazardous elements in the output of waste and water. I think that's all from me. I will pass to the next presenter.
Now, I would like to present the analytical design for Journal 1, which is TDA-AAS. For the calibration, According to the manufacturer guidelines, calibration were carried out by waving at the cost of 0.1 and 1 mg per L mercury calibration solutions into the quartz pot after first establishing that blends did not give any detectable responses. Next, for the optimization of method parameters, 250 degrees Celsius was chosen as the maximum starting temperature. Experiment run periods and temperature were set according to the instrument manufacturer's recommendations. For the sensitivity test, quartz pots were fortified with 0.08 nanogram from white seeds that produce no measurable mercury signal, while empty quartz pots received 0.08 nanogram mercury. Next, for the limits of quantitation, the TDAAS procedure were used to analyze 5 color additive samples with 1 mg per kg mercury or less. The limit of quantitation were calculated as 10 times the standard deviation. The TDAS method was run more times to make up for the smaller portion size that was analyzed. And lastly is routine color additive testing. For several months, all color additives submitted to the FDA for certification testing were routinely analyzed for mercury content using the optimized TDAAS methods. While all color additives were routinely evaluated by the TDAAS, the equipment required frequent catalytic changes.
For Analytical Design Journal 2, contribution to the study of selected heavy metal in urban wastewater using ICP-MS method, first is water sampling. To do this experiment, municipal wastewater treatment plant and purified wastewater were selected. Secondly is chemical analysis. This experiment was subjected these two samples to a basic chemical analysis. Lastly is inorganic mass spectrometry. The ICP-MS method is one of the most used methods of inorganic mass spectrometry because it allows for multi-element analysis.
So I will be presenting about the theory of operation. The first is ICP-MS, inductively coupled plasma spectrometry. ICP-MS is an elemental analysis technology capable of detecting most of the periodic table of elements at milligram to nanogram per liter. The inductively coupled plasma ICP is an ionization source that fully decomposes a sample into its constituent elements and transform those elements into ions. It is usually composed of argon gas, and energy is coupled to it using an induction coil to form the plasma. Next is AAS. The absorption of light by atoms provides a powerful analytical tool for both quantitative and qualitative analysis. Atomic absorption spectroscopy (AAS) is based upon the principle that free atoms in the ground state can absorb light to a certain wavelength. Absorption for each element is specific. No other elements absorb this wavelength.
For data analysis of TDAAS, as you can see, it consists of two tables. Table 1 shows the summary data and estimate limit of quantitation for 5 color additive with 1 mg per kg mercury or less on 3 different techniques. Based on Table 1, samples of color additive representing various types of dye classes were tested for mercury by the TDAAS method. Next, for Table 2, shows the comparison of some example of color additive that produce values over the 1 mg per kg mercury specification limit. Next, based on the analysis, the limits of quantitation estimation may have been affected by sample homogeneity due to the use of the vary portion size in TDAAS method. The TDAAS method employs 0.0 g portions, while the ICP-MS method uses 0.1 gram portions. In terms of limit of quantitation, the TDAAS approach was the most accurate as the limit of quantitation in color additive in ICP-MS is around 0.1, which is higher, despite that the fact ICP-MS has a great sensitivity for analytes in solution. However, samples like F and D blue number 2 for TDAAS had higher estimated limits of quantitation values because they seem to be less homogeneous and showed larger variation in findings for smaller portions.
Data analysis for inductively coupled plasma mass spectrometry ICP-MS. Table 2 show the result of the basic physicochemical properties of sample that were analysed for each wastewater sample after the analysis. Results show the inlet and outlet of pH, conductivity, COD, solute and suspended solid. These wastewater samples were analysed by ICP-MS and AAS after stabilized with nitric acid. Table 3 shows the inlet result obtained by AAS and ICP-MS. EQS, MAC were used to compare the result. Inlet result and the concentration of the metal Pb and nickel is lower than the set limit value for EQS MAC. Table 4 shows the outlet result obtained by AAS and ICP-MS. The sample of wastewater treatment meet the EQS MAC in all parameters used by using ICP-MS. So, in this analysis, ICP-MS can detect the lower concentration.
In conclusion, ICP-MS is a multi-element technique that dissociates a material into its constituents, atoms or ions using an ICP plasma source. AAS is an analytical technique for measuring the concentration of a wide range of elements in samples, in which the free atoms in the sprayed element solution absorb the radiation of the studied elements follow cathode lamp. Both of these methods have advantages and disadvantages when it comes to identifying heavy metals.
Before we end our presentation, I would like to discuss a little bit about the future prospect. To overcome the deficiency for both ICP-MS and AAS, future prospects need to be considered. For the use of instruments in the future, ICP-MS will be the great option compared to AAS in determining heavy metals. Even ICP-MS will be the best choice, this instrument still need to improve for its certain functions. So now, I will start with AAS. What are the things that can improve for AAS? Firstly, its low sensitivity. The fact that it can only test one element at one time and its lack of linearity. So, the things that can be improved are its limitations, where the sensitivity could be increased as well as the AAS could test one or more elements at one time. Next, AAS can improve its simple method. AAS shows less data collected compared to what we get from ICP-MS. Therefore, AAS is a decent instrument that is low cost and the detection limit also reasonable depending on the analyte metal type. Now, let us talk about ICP-MS. Things that can improve from this instrument are designed in order to reduce the depth volume of trace metal contamination that can be found in ICP-MS blanks. If the design is not improved, it could lead to a waste of a part of the analytical capability of a costly instrument. Besides, ICP-MS can be improved by reducing the matrix effects because the concentration of matrix components in plasma reduces the sensitivity to analyte ions as well as the accuracy of the ICP-MS. Moreover, the matrix components also have the ability to reduce the analyte sensitivity. So, that's all from us. Thank you.